we got to start it.
Yeah.
In the beginning, that works if you need it.
Okay, but they can do that. I don't need it, right? All right. Hi, everyone. We're going to go ahead and get started. So welcome to the most exciting panel at NY-GEO this year, the Global Thermal Energy Network Momentum. And this is our opportunity to learn what's happening in the rest of the world and to actually be inspired. So I'm Ania Camargo. I am on the HEET Board of Directors, and I have an amazing group of panelists with me. So let me just introduce them quickly. So Mikko Ojanne from Rototec Europe. He's an entrepreneur, founder of Rototec, with experience from building companies in geothermal and property sectors. He is also involved as an investor in private equity. We have Eric Bosworth. He's the principal consultant at Thermal Energy Insights. With 15 years of energy industry experience from upstream O&G to renewables, he provides technical consulting services to utilities, municipalities, government agencies, and private companies on a wide range of energy and policy topics. And my addendum is that he also led the implementation of the first utility geothermal network installation in Framingham, Massachusetts. And we've got Zeyneb Magavi. She's the executive director of HEET, where she pioneered gas to geo using geothermal networks. She serves as a senior advisor to the IFC's geothermal network program. That's the International Finance Corporation, and has background in physics and global health prior to her work in clean energy. And then finally, we have Miles Ingraham. He works at Jacobs, and he is a multidisciplinary geothermal design manager with a decade of experience across civil engineering, mechanical systems, hydrology, and geo-exchange infrastructure. He has served as a subject matter expert on large-scale industrial, commercial, and residential projects throughout the United States and overseas. So welcome, and I think we are going to go ahead and start with Eric. It's the order of the slides.
All right, I guess I get the pleasure of being first here. A little unexpected, but we'll make it work. Thank you, Ania. As she said, my name is Eric. I am the principal at Thermal Energy Insights. And I'm going to be talking a little bit about two regions that I have worked in recently. Ania mentioned the IFC, the World Bank work. I've been also assisting with that. And the focus regions are kind of the Middle East, Central Asia. So I'm going to start out there and talk a little bit about some of the value drivers in these regions, the types of projects that are being evaluated, and kind of why geothermal or geothermal networks are being considered in this part of the world. So for those of you unfamiliar with Central Asia, here's a nice map of the region. And it's a part of the world that honestly doesn't get as much attention as it really should. It's got extremely interesting countries. It's got a very diverse climate as you move from the north to the south. But from an energy perspective, they're also quite unique, speaking as somebody from the US up here. You don't realize how when a country is dependent on their neighbors for the majority of the energy that come into the region, geopolitics have a big impact on the everyday lives of the people that live there. And so Central Asia is one of these areas that's interesting because pretty much the entire area was at one point part of the USSR, which means, as you can see in that image down there on the bottom, they've got old Soviet infrastructure that they are still using today. So that photo is of above ground steam network pipes that you see throughout this region, and they were mostly installed in the 40s and 50s. So they are still using this infrastructure. It is extremely leaky, it is extremely inefficient, and it's all well past end of life. So what you end up with is a situation where the country is looking at this infrastructure and saying, we know we need to do something. Are we going to wholesale pull out these districts and put in new steam districts? Do we move to hot water loops or kind of fourth generation districts like much of Europe has? Or do we potentially piggyback and jump all the way to ambient temperature loops? And that's where, this work comes in as we talk through those options and do essentially feasibility analysis for a thermal energy network in a lot of these countries. And so while the value drivers aren't the same, the good thing is we know the technology works. So when you walk into conversations with an energy ministry, for example, you can point to systems in Canada that are running in similar climate conditions. Or if you're in the south of Central Asia, you can point to systems in Texas or in cooling-dominated areas. We know the technology works. It's really about what is the fit for this specific application, this specific country, and what problem are we trying to solve. So the last point on Central Asia is when they're evaluating systems, they're not doing it at the 300, 400, 500 customer scale that we've been talking about mostly today. They're talking about 3,000 to 30,000 customers on a system. And so you're really getting those economies of scale, and as you run the economics, it's a very, very different picture from a small demonstration pilot if you're trying to convert an entire city, or they're building a new city and they may want to put a thermal energy network in. So it's interesting, it's exciting, and it's cool to see how the same technology deployed in a different part of the world has vastly different economics, even if the technical performance is quite similar. The second area I wanted to talk about is in the Middle East, so Jordan, another country that we looked at countrywide feasibility for. And the theme of my talk here is that the value drivers are very different there than they are even in Central Asia. Now we're in a country that is cooling dominated. Yes, they use some heating energy, but for the most part, they're trying to figure out how do we keep our buildings cool through 8, 9, 10 months of the year. And on top of that, they're extremely water constrained. And so from their standpoint, yes, there's energy security, yes, there is performance and limiting the strain on the grid, but there's also the issue of we don't have access to a lot of water, and we have higher and better uses for it than putting it through evaporative coolers. And so when you run the economics in a country like Jordan, those water costs and that performance of the system really stand out, and it becomes an interesting place that you can demonstrate some of those other value propositions. The other thing that I'll say is we were actually very pleasantly surprised at how reasonable the energy balance was, even in Jordan, when you ran the numbers on the actual building loads. There are a lot of ways to move thermal energy, and there's a lot of different sinks that you can get aside from just geothermal boreholes. And when the numbers were presented to us, there are certain parts of the country that have very, very heating and cooling balanced loads, even if you wouldn't think it at first. So as you look across a region, across a country, you can always find pockets and areas where the technology can really shine and perform well. So I tried to keep it light on slides here today. This is actually my final one, but kind of bringing it back to what those value drivers are in other parts of the world. And I like this diagram on the right because I think it really encapsulates what we see from different regions and how energy security ends up playing such a big part of it, whether it's getting your energy from a foreign country that may or may not be an adversary and your supplies may or may not be disrupted at the drop of a hat, to something like environmental security, where you see countries and cities that are really struggling with air quality and carbon emissions. You can find the value drivers pretty much anywhere, and it really is a question of looking at the picture holistically, figuring out what problem you're trying to solve in a given country, and then running the numbers for, can we do this efficiently and economically? And as I've said, surprisingly, the numbers do look very, very good in a lot of parts of the world, especially if you're doing it at scale beyond just an initial demonstration. So with that, I think that's the end of my slides, and the next up is Zeyneb.
All right, my challenge is going to be time. I'm going to set a timer, people. So first of all, I think that all of the panels are the most exciting. Just saying, in this track, in this room, sorry. It's amazing to see all the progress, and I think that's part of the relevance of talking about the global momentum here in New York, is that kind of like the Goethe quote, like if you cannot know your own language until you've learned another. I think there's a tremendous amount of learning and relevance for us here by looking elsewhere and understanding the other panelists. So talking about four different locations and about how their context creates the opportunity in different ways for each. So starting with Ukraine, then briefly on the Netherlands, Turkey, and Pakistan. So first of all, there is no greater and more impactful, maybe even gut-wrenching lesson than that energy security is national security, as Ukraine has understood. And the whole world has been watching this. Tactical removal of energy infrastructure is a war strategy. So we were really honored to host a Ukrainian delegation, including a number of municipal mayors, as well as a country regulator and some others, and gave them a great tour, and thanks to Eversource for hosting as well. The question that stuck with me long after, aside from the homemade dumplings they made, was so with this infrastructure, as we're looking around an empty parking lot, because GEO tours are scintillating, right? Like you can see so much. With this infrastructure, what happens when a bomb strikes it? And we paused and said, well, we don't have any data, but whatever happens to your water system is probably about it. And they're like, oh, excellent. But I think that's a first place to start, and it's an extreme place to start. And so now there are a couple of municipalities that are moving forward with the idea. Of course, at the moment, things are not going that well over there, and I wish them so much luck and peace. So the process of learning together, I think, was incredible. The Netherlands. Tomorrow morning, I have the pleasure of remotely speaking at a one-day conference that's called ZLT. And apparently that means very low temperature. And there's a group in the Netherlands who is leading the push to look at the 5th generation or very low temperature ambient temperature loop, and are very excited about gas to geo, the idea of gas utilities building it. And partly there is a very interesting context. The Netherlands was one of the very first places in the world to legislate and mandate a transition off gas very concretely and incrementally. In 2019, they made the mandate to be off gas by 2050. They've got incremental requirements by municipalities to make concrete plans. They halted their gas production in 2023, and now all gas boiler replacements must be heat pumps or hybrid starting this year. And that's a very large move, and so there has been a scramble for solutions. So the idea of a thermal energy network, and specifically the single pipe ambient temperature loop, is starting to grow there, and in that context to solve that problem. And that focus on the gas to geo pathway, which utilizes a utility scale, is part of what drew the attention of a number of multinationals, including the World Bank's IFC, International Finance Corporation, and really specifically because, and in the video that's linked here, it unlocks the financing capacity to scale large infrastructure. So the idea that an individual building heat pump, geothermal heat pump, needs the upfront financing, which of course leasing does as well, but their focus, of course, was on finance and the unlocking of finance. And so the idea of utility scale was very attractive. And furthermore, it met a whole series of sustainable development goals. And with a certain amount of investment allocated towards sustainable development goals, but the need to match that with something that the governments wished to invest in, created a new program at the World Bank around geothermal networks, launching feasibility studies, one of which Eric just spoke about. So I'm going to speak about another one of them. Turkey, and pictured here is one of the first presentations to the Ministry of Energy, has a very interesting context. The current government, which is headed by President Erdogan, or I think President, so he, a large portion of his power in the country and affection by his voters are around a campaign promise to bring gas to rural areas. In fact, it's one of the most extraordinary gas system build-outs I've ever heard of. They went from a 30% to a 70 to 80% penetration of gas to buildings in less than 10 years. And that build-out was done through privatization, and they have now hit the remaining commitment where they said every municipality over 5,000 is going to get gas, and you're going to be able to get off of the little wood-burning stove, which I stuck here because that was the past. But some of those 5,000 home towns are actually quite remote and or challenging or not very cost-effective to bring gas to, and so that's the context within which the geothermal network first became attractive to the government. It's like, oh, we could keep our promise to provide the provision of thermal. It could add cooling, and so the process began to look into it. Across the country, there's a very wide geological diversity, and some of the projects initially are coming back with an 8 to 15% IRR and a payback of 4 to 16 years, which is pretty phenomenal. On top of that, they have a heat pump manufacturing industry and are interested in growing that. And I think the other piece that's pretty interesting and critical is that they are currently subsidizing gas. And it's mostly purchased from Russia. And so there's a geopolitical and economic driver, given that some of the initial work showed that the geothermal network could outperform subsidized gas, so reducing subsidy dependence. And that has become one of the key points. I included a comic picture of Eric staring at a very interesting, maybe rapidly deployed gas hookup. Pakistan is the last one I'm going to briefly talk on, and I thought it was perhaps the most fascinating. They are a country that built out its infrastructure in the 40s of last century, and they had some gas production, which has been depleted faster than expected. So they began having to buy gas on the spot market at LNG at very high cost, right as Russia invaded Ukraine. And now, needless to say, the cost is also high again, as most of their gas supply comes through the Straits of Hormuz. So the gas prices shot up, and they've had to subsidize gas to all their gas customers, which is in the range of 75% subsidy. Well, that's not a sustainable utility, is it? It's really a utility in a death spiral. How do you invest in your infrastructure? How do you keep it safe? And at the same time, that cost of gas drives their electric generation, and the electric system started to have blackouts. It needs investment. Well, on top of all of that, there was this incredible opportunity from China with incredibly low-cost solar panels and batteries. And they have one of the most extraordinary solar build-outs in the world. It's been covered by a bunch of news agencies. 5 times multiplication from 2021 to 2025. And the context of that creates an interesting death spiral on the electric grid. So without a lot of A double death spiral is a pretty unusual electric and gas situation. In that context, we got to visit the first geothermal install in Islamabad, and I had to include it for this crowd. It's this building, the new National Energy Efficiency and Conservation Authority. It's currently up and running. We were there to see the borehole drilled, and that is the drill, people. It's called a buggy, apparently, and I still haven't figured out how it works, but I'm putting it up here for all of you to evaluate. The hole did seem to be a hole. Just saying. So, in conclusion, I really think the biggest takeaway that I've learned and understood that's relevant to us here is that energy systems are the basis of the economy and human well-being. And that aging energy systems mean we have a question of how are we going to invest in the future economy and our future well-being. Yes, it is also national security. Yes, system efficiency drives affordability and grid impacts. And geothermal is rock-solid, local, and price-stable energy, and that appeals across the world. Of course, also, lesson after lesson, place after place, our changing climate is an existential threat. So I think it's super important for us to look outside of New York and outside of New England and the US and understand the context of what we're doing, and also to understand that what we're doing here is actually being watched, picked up, and replicated across the world. So thank you.
Hi, everyone. Thank you very much for joining today. And yeah, looking forward to presenting on my topic, which is global trends in the defense industry for thermal energy networks. I'm Miles, and I work at Jacobs. We have a global presence, so we work across the globe on various engineering scopes. Many of these countries in which we work for the thermal energy network space and district energy systems. So globally, what we see, there's lots of utilities that are interested in this technology. We have cities and municipalities that are developing thermal energy networks, neighborhoods even, co-ops. We also see wastewater sectors trying to decarbonize and to reduce effluent water temperatures, so trying to find opportunistic waste heat offtakes to those. We also see data centers, food distribution centers, campuses, private industries. But today, I wanted to focus on the government agencies, which are really starting to take advantage of this technology, which, you know, despite our lots of conversations of pilots and studying this, is at a high technological readiness to be deployed across the world, especially within the defense industry. So the U.S. defense industry has definitely taken a keen eye to this technology. So we've worked on a couple different projects, and so what I'll be talking about today is two different projects. One's in the United Kingdom and another's in Japan. So for this project that recently came up, so we've been looking at thermal energy networks, the feasibility of thermal energy networks in comparison to incumbent technologies, including standard electrification, gas, and individual ground source heat pumps at dozens of buildings on this facility somewhere in the United Kingdom. And the motivation behind this is really trying to reduce the delivered fuel that these facilities tend to get. So since, let's say, World War I, fuel has been delivered to these bases in the same exact way that it is today, either through oil, gas, or some other fossil fuels. So there's a strategic interest to be looking at electrification at these bases just for the security itself and to reduce the supply chain issues that, you know, especially in the last month, we've seen plenty of. Some of the key outcomes from this study were that thermal energy networks were the most cost-effective, but also increase the resilience and reliability of their systems over all the other technologies. So looking at both performance and for cost, thermal energy networks won out. This facility had lots of simultaneous loads, so that was another reason why this showed such favorability. despite being in the UK, it was actually cooling dominant, but most of the year it was actually sharing, lots of buildings being able to share that energy back and forth. So that's one case example. The next brings us to another corner of the world, to Japan. Similarly, they were looking to reduce fuel supply to this base in Japan, which is not pictured here. And what we found was that, by installing a thermal energy network, we could reduce that energy consumption both by cost and by fuel delivery by 40 to 50%. And another thing for this site was that it was brought to our attention that facilities management is not a core mission. They have other things to be dealing with on these bases, and they don't want to be dealing with failing mechanical systems. They would love to just set and forget and wake up 50 years later and then replace it. But I would not recommend that to anyone. You should definitely maintain your systems as best as you can. But for a thermal energy network, that is a little bit more, that's more possible, is to have a lower overhead of facilities management with this type of system. So that's why we're seeing such interest in it in the defense industry, because they have other operations that they need to take care of. And for this site, we had lots of different drilling areas, which was great for being able to install enough bore fields and do the design for that. Again, great load diversity. These facilities have lots of different different building types with different profiles of energy consumption, and so that makes them definitely attractive for thermal energy networks and for enabling that sharing between buildings. Some other interesting outcomes from this project were that there were permitting issues. Of course, we're international here, so it's not just, there's plenty of challenges here in the US, but if you're doing this internationally where there may not be lots of geothermal industry there, that can be a challenge. And then there's, of course, working with a large government agency, especially abroad, there's a lot of administrative burden. And lastly, most naval facilities or military bases have some level of contaminated soil from their incumbent technologies, and so that's something else that we need to be looking for when we're installing these abroad. And so, wrapping up, we have lots of different benefits for defense facilities with this ready technology, and many of the benefits are exactly the same as you would have on a single home ground source heat pump or a large utility thermal energy network system. We get these reductions in water consumption, which can improve your greenhouse gas footprint, reduce the water consumption, take advantage of opportunistic waste heat sources that are on site already and that are just being wasted out stacks. Those can be leveraged for different building consumption needs. And then lastly, on the energy security side, this lowers the electrical peaks, frees up electrical headroom in a lot of these facilities, which could always use that, and also integrate more readily with microgrids, which are becoming a more attractive proposition at military bases worldwide, to really go into island mode and not have this supply chain issue of having to deliver fuel to the sites. And lastly, this, as Zeyneb had mentioned, this is a little bit more secure in the sense that this is underground infrastructure. It can go inside a building if a bomb hits it. Lots of times these are modularized, and so we can account for that in the design. So it's a really exciting prospect, and it also shows that the U.S. government is actually kind of behind this technology, despite certain top-down approaches towards renewable energies. This has really kept its pace and is really at its technological readiness, as proven by being developed on military installations. So, thank you very much, and I'll pass it on to Mikko.
Hi, I'm going to talk about district heating in Sweden and how we work together and what we can do with the current district heating. There was a Swedish district heating company which owns around 100 small sites, and they called me a couple of years ago and asked me, can we use something geothermal together with district heating? I had a meeting with them and say, yes, we should look into that. That can be very interesting. Of course, it's very challenging because you have high temperature system, etc., and so on. But luckily, they are owning small sites, quite small sites in Nordics. So we start to look into one, and I will show you today one of the case we have here. It's located 15 miles from Stockholm, capital, and there is the lake. They have actually today heat pump solution there. They are using open loop systems that are actually pumping the water to the heating room, or how is it, heat pumps technical room. Here is a little bit information that was installed 1985, so it's almost 40-year-old system what they're using today. So they're feeding the heat pump with the water from the lake. And then also they have biomass or biofuel heater there. So this installing have been very like 40-year-old, and it's starting to be on the end now, so they need to do something. But there is also, we see also the heat pump have not so efficient anymore, and also about if you look to the heat pump, what kind of GWP is, so it's very high, so then they need to find something which is more environmentally better solution for that. And then we start to discuss with them that if they want to continue with the lake solution, that they are taking the pumping up the water from the lake and combine together with geothermal, because there is also benefit when they are municipality like this solution today, because they are feeding create the circulation to the lake, which means that the lake is like, how we say, the life for the fish and stuff, animals, it's holding fresh there. So, and what we are looking for there is solution there. We have built in Finland this heat pump, and there is not Rototec who is building the heat pump, but it's a Finnish company who is involved in this project. There we will use natural refrigerant, which means that we can raise up in 2 stages to the right level of temperature. And we have also designed there 300 boreholes, which 1,000 feet. And we will do it together with the pumping water lake solution. They have today, even there in the lake, they have actually closed loop together with the pumping water, but we will take off the closed loop there and replace that with geothermal boreholes nearby. They still gonna have biomass boiler because they're gonna peak, which means that it's better to use when it's in Stockholm region. We have maybe 3 or 4 weeks extremely cold weather. Then we are using biomass if we need it. Yeah, that's actually my presentation. Thanks.
All right, thank you. That was terrific. So I'd love to open it up for questions if anybody has any. There's a... Yeah, coming. She's coming to you.
Thank you. Tony Gelber from Pratt in Brooklyn. Anybody using steam as the output from the heat pumps? I see a smile. I've read some of your online propaganda, to use a bad word, and I see that that is possible. All the waste heat that I'm seeing in factories and in EU this and EU that, now being able to change to steam. So who's going to raise their hand and sell me steam?
So in the country, yeah, speak to Greg. Con Ed has a wonderful steam system. But no, the trend that I have mostly observed is in almost all of the cases, everybody is looking to go to lower temperature distribution. And so the folks that are operating these old USSR steam systems really, really don't want to put another steam system in. They want to go to ambient temperature or maybe a two-pipe system in most cases. So there are districts out there that don't need to be replaced wholesale. In the specific countries I was talking about, though, they're looking at new installations. And I don't know that I've spoken to anybody that has said, can we do a steam system that has a heat pump and GEO on the back end? The only time it comes up is when they're looking to maintain the pipes they have in the ground and they're trying to figure out a way to decarbonize the steam itself.
I'm wondering if you also might be getting at, the kind of trade-offs equation of if you have a large old building that you don't want to change the mechanicals and it requires steam, there are some products out there that can step up from an ambient or lower temp waste heat to steam that are beginning to be on offer. I'm not selling anything, but I know there's some that are in development. And then the reverse, I second what Eric said. No one's looking to wholesale put in a steam system. It just has more losses, higher inefficiency, and a shorter lifespan, and increases corrosion underground with electric systems. So everyone's moving towards more efficiency and coming down in the temperature range. I think the question with steam is, if you have existing steam, can you use it as a peaking source to a lower temp or ambient system? That's a cool idea. You could cascade with what you've got. And then if you have a mechanical system that you don't want to upgrade, can you step up? And so those are the two places where I see it playing out. I hope that answers.
So I have an expression: love decarbonization, hate the costs, right? So yes, thank you.
Any other questions?
Sorry, I'm just going to respond to the cost piece. I think that's actually one of the things that a number of the projects that are at scale in other countries is informing, is that if you have a cost framework and a cost equation that includes a lot of the other externalities like the water savings or the grid savings, and you're at scale, not doing these small networks of a few homes, the cost is lower. It's coming out in a lot of places least cost of any energy system infrastructure. And I think that's something we really have to look at.
Hi, Claire Doyle Dowd. I'm with a company called Micro Era Power. Enjoyed the panel quite a bit. I had a question for Miles, really just around kind of in the United States, the Department of Defense, kind of the vast number of bases in the United States and kind of the entry point and really kind of the need for improvements of aging infrastructure, military housing, air quality for, service members. And if you see tolerance, for lack of a better word, of innovation in that space right now in the United States, if you have experience with that.
Yeah, absolutely. It's, I would say, definitely taking off here in the U.S. as well, not just abroad. But one of the reasons, of course, is the resilience, but a lot of their infrastructure is aging, so now is the time to be converting it to something that's more efficient. And they can also take on that cost burden because they have the funding, and then they have the infrastructure to be able to develop these projects at a larger scale. and they're also converting off of steam and central systems, but they also have lots of dispersed mechanical systems, a lot of times that are just patched together and just meant to get through the year or two. So I think there's a lot of interest for operational readiness to be doing these wholesale retrofit packages for large portions of campuses. And of course that contributes to reducing pollution, which, as we know, military bases have significant amounts of pollution, not just from oil or petroleum products, but lots of other chemicals as well. And so reducing any of that we can is going to be a positive thing for, security. Yeah.
I loved your question, and 2 weeks ago, one of Miles' companions and I were at the first ever all-day presentation and workshop on thermal energy networks at the Department of War's Innovation Symposium. And they are really excited about the potential and also facing, in some ways, a lot of the same problems we're all facing in terms of, how do you account for it? How do you do the cost accounting? What is the right scale? How do you get the workforce to deploy? And one of the things they're actually interested in, because the department doesn't have a large allocation of its budget to building maintenance, so it happens in surges. They're very interested in local gas utilities providing them a thermal energy network in order to increase the resilience and the energy security and price stability of their bases. So that's something to put out there as well.
Good afternoon, Brock Yorty, Geothermal Drillers Association. From these global project perspectives, obviously we have a Rototec up there, and that is awesome to be able to get the dirt moved and execute. But Zeyneb and Eric and Miles, when it comes to building this infrastructure and the workforce, the hurdle we're seeing here in the States, how are they handling it in these other countries?
They're open to learning, Brock. No, I think that's generally a big part of the conversation, especially if you're not in Scandinavia or the US or somewhere that has a developed market where we're putting in geobores already and we're saying, how do we scale from a small industry to a large industry? Some of these countries, they're literally looking at building the industry up from scratch. And so you have a lot of conversations around what skills exist already, what would that training need to look like, and what specific things would people need to learn. Heat pump installations, right? They do a lot of air source maybe, they don't do ground source, so that's a training gap that you need to fill. Even with drilling, maybe they're used to drilling water wells and they haven't put geo wells in, so what does that cross-training look like? It's an active discussion, and it's a point that you bring up, but the industry evolved here, and so other countries have that capability as well. And one final point that is a positive is project costs tend to be very labor rate driven, and in some of these countries, you can get some really attractive economics at the labor rates that they will be doing drilling.
And while giving people a livable wage, just saying. That's part of why I put up the picture of that drill in Pakistan and the first geothermal borehole is, most of the projects in a lot of these places will require importing expertise in the beginning, but also there's a really great opportunity to kind of build it well from the start in terms of policy and regulation and everything else and training. And there's a lot of interest in different countries, like in Jordan. Turns out they have some really great bentonite reserves, and they were very excited that potentially they could produce grout for the region.
And I don't want to put you on the spot here, Mikko, but I'm sure you guys have been doing a lot of knowledge sharing as well with the length and the history of geothermal in Scandinavia and other regions that are starting to adopt it. Is that accurate?
Yeah, I'm from Sweden, and I'm born in Sweden, but I have Finnish parents, so I start a company in Sweden and move over to Finland and start geothermal business there. And that time, the geothermal was very, very small part of the business. But actually what we do was that we educate and, starting to find actually the issue where we can help them to be more efficient. And today, I think that it's from 2007, we have grown in Finland around 20 times that market size. And we are using more and more geothermal for data center, military project. Now it's like district heating. So that means that we need to be close to our customer and understand also what actually they need, or where is the problem. When they have the problem, then we can find a solution. That's a little bit the. So I think it's like they are not coming. The normal customer is not understanding what they actually can do with geothermal.
No, so I was just going to say, it sounds to me like a lot of these international places, it's very from the top down versus what it's been here, which is from the bottom up, it feels like. And I'm wondering how these countries are thinking of addressing all of the consumer education and acceptance and the supply chain issue, all of that, those other pieces of this versus just, so I'm wondering if you could share. I mean, it sounds like, Mikko, like you've had the experience if you grew up from the bottom up, but the top down is different. And so I'm wondering how that's being handled in these projects that you're seeing.
Happy to start. The top down is an interesting approach. There are, in my opinion, pros and cons. On the challenges side, to your point, you do still need to educate, you need to explain to people what you're doing and why you're doing it. And so actually taking a lot of the work that's been done here in terms of stakeholder outreach and figuring out how you map that into a new country and a new culture is critically important. On the pros side of things, I've probably told you this story before, but it's very interesting to be working in a country and identify something like a legal gap where you say, are you sure you can legally own a thermal energy network? And they turn and look at you and say, well, then we'll just change the law. And so there are some benefits to the top-down approach if you're trying to do big infrastructure projects and you have the support of the country level decision makers, it'll get done. And so it's a very strange dynamic between what we're used to with lots of rules and regulatory filings and time, and it's a lot of effort. Sometimes the top down can actually move quicker as long as they're doing it properly.
My first thought is the pictures from Pakistan, there was actually a very similar to Massachusetts and New York, very broad level of many different stakeholders and groups that came together for each of those cities, which felt a lot like here, actually. And the piece that there was just near universal understanding and agreement was everyone felt and experienced and understood how critical their energy system was to their lives and their economy and their country, and in a way that I don't think all of us really do. We don't experience outages and risk in the same way that a lot of other places do. And so it almost felt like there was a stronger, broader alignment in those gatherings. And I think that might be an advantage. If you can get both, if you can get top down and bottom up, that's the best.
Yeah.
So I have a question. This is Ojanne Kendall from Aztec Geothermal. Mostly for Zeyneb and Eric, but anybody could answer. What are some countries that didn't make your list today that you might be working with next, or that you might want to work with next, but you don't have time or resources, but maybe somebody should work with them?
I'm an all of the above kind of person, but actively right now, I'm actually making an effort to connect with more people in Asia, in Southeast Asia, in Eastern Asia. I think that there are a lot of great projects going on there that we don't necessarily hear about, and to me, that's lost learning. That is, if they're doing an airport in China or Japan or Korea, and they're putting in a few thousand bores, and we don't ever see any data or any kind of a report from it, that's a shame. And so getting more involved in more global projects just for that learning sharing, I think is really, really critical.
I was totally going to say South Korea, where they have an enormous amount of geothermal work, and China. I wish there was more data flow where we were learning more about what they're doing, because China is now the largest geothermal. I think they just surpassed Sweden. And I'm actually going to turn it to our moderator, because we've had some meetings in another country.
So in Colombia, we've been looking at geothermal networks in Colombia in moderate and low-income housing, because the electricity is really expensive, and there are a lot of really hot. It's on the equator, so it's a huge challenge to provide cooling. And so this was going to be a potential solution. The problem that we have, and a challenge to put out there, is that it's so cooling dominant that we have to find a place to put the heat. And so there, obviously swimming pools and water, and they can create tank. But how can we do this? My challenge to Zeyneb was, can she please generate some electricity from all of the heat? Can we somehow, because there's so much heat that we need to put somewhere. And obviously you don't want to put it in the ocean, and you don't want to put it all back into the ground. So that's been a challenge, but we're working with folks down there trying to figure out a solution. If anybody has ideas, would love to talk with you. Any other questions about anybody from an interesting country that wants geothermal networks? No, go ahead. Go ahead and ask any question.
Okay, I'm gonna stand. Hi, my name is Alicia Jenkins. I work with Sierra Club Connecticut. I thank you for the panel. Thank you. I'm interested to see, and I know this is a tough, I might get some backlash for this, but in regards to what's going on in Cuba, I wonder if any of you all are interested in doing any work there, because I've been to Cuba twice, and I know the young people there want geothermal and solar, but they are right now struggling because their gas is off, and I just wonder if you all are interested in that.
I'll be the first. Island nations in general, I think, are well positioned to adopt the technology. I have talked to a number of different folks, be it the Caribbean or the Greek islands or even places like Hawaii, where they import so much of their fuel via ship that any amount of load that you can offset with a local system like this has huge benefits. I think it's probably similar to what Miles was talking about with distributed bases around the world. Once you have to move the fuel and import it, the value proposition changes dramatically. And so I'm a huge proponent of any and all islands that can deploy a thermal network should be evaluating it, and run the numbers on a sea exchanger as well. I don't want to set Zeyneb off too much here, but it's a huge resource that we potentially have that we're not necessarily using.
Yeah, just want to second that. And yeah, I think a lot of island nations and places that have insecure energy should be looking into this technology because it's worth it. And yeah, that's all.
I am terrible at saying no, and of course it's interesting, and if the energy system can be built to help the people thrive, that's to me kind of the core point. And especially in a situation where there are such challenges, it's even more important. And yet, like learning from Ukraine, it's those situations where there are a lot of challenges that it's hardest to move forward with building something, and funding and all of these things. And so the irony is that yes, it's the making it happen and the funding it that is so challenging everywhere. And I think that's something I don't know how to solve.
Yeah. Oh, there's one more question. Great. Last question.
Except building them everywhere when you can. Right. So that when you get in that situation, you've already got them. So, yeah.
So, Tony from Pratt again. Question. In places where the grid is now constrained, and we know that in a lot of countries that is more of a condition than any of us would like to understand, no. When you look at converting one of those types of places to geothermal, yes, you get a better load profile, you get reductions in overall use, but how do you rely on that unreliable grid to support that power, that geo system? And so how do you overcome that problem?
I think that's a really, really important question. And, you know, that was part of the conversation in Pakistan. And a build out of a geothermal network coupled with solar and batteries was really what they felt comfortable discussing, because they've already got a very large solar and battery market and a lot of faith in that as a technology at this point. The place where there was a greater challenge was Tajikistan, which has, it's a small, beautiful country that I hadn't ever paid attention to, and has a really limited electric grid. They're building a massive dam, but it hasn't happened yet. And the water level is dropping due to climate change. So they're really grid constrained, severely grid constrained, and have coal-burning power plants. And they were very concerned about the electric grid reliability, but basically pointed to the future dam as the source of that future reliability, which felt to me very uncertain. So I would describe that as a place where it may be a handicap to the system.
I'd just second that and say thermal energy networks, geothermal are great. They're not going to solve every problem. And so if you have an unstable grid, you're going to need to address the grid and the grid reliability as well. The stable load profile helps. A lot of times these grids go down on a peak summer day when everybody is running AC and some commercial load comes on at the same time. But you still need to solve that problem one way or the other. Simply leveling out the load isn't a long-term solution.
Yeah, and I just want to add, so, you know, locally what we see is in New York City, for example, it's a summer peaking, but if we went to the thermal energy network, you know, Zeynep co-authored the Falcon curve, which shows these different heating COPs, what that does to the peak electrical load across a piece of infrastructure. So if we're going to electrify everything, it's gonna still bump that up compared to just doing thermal energy networks and never electrify cars, for example. So there's always going to need to be some electrical grid infrastructure upgrades. It's just where you do it and where those pinch points are. But yeah, that has to be studied case by case, I would say.
So you're saying geothermal doesn't solve everything?
It is part of the symphony.
Okay,
I would
adios.
say it is part of
Almost
the symphony.
everything. Well, there's a hand up if it's a really quick question.
Yeah, just, sorry, Bob Wyman again. Just observation. You're talking about leveling the load when the supply is uneven. An opportunity that people really don't often pay attention to, but they should, and that is we have now uneven supply from things like wind. Wind is really great during the winter, and it's really great at night, but that's not when we have today, when we have our peaks. Our peaks are during the summer and during the day. The really cool thing about bringing geothermal heat pumps on, and heat pumps in general, is that they consume more electricity in the winter and at night, okay, when it's colder. So one of the cool things about geothermal is that it actually adjusts the load to meet the supply, okay, which at the moment is kind of unusual. So if you have more heat pumps on your network, you will curtail your wind resources less, which means that your wind can now be considered cheaper. It'll have a faster, a better return on investment and a faster payback. That's one of the real distinctive advantages of geothermal that I think really should be recognized more.
Thank you, Bob. Okay, so thank you, everybody. Thanks, panel. And I think now we have a nice half-hour break, right? 15-minute break. Thanks.